So in this video, we are going to take up one more problem, how to analyze this given problem and solve by using manual drawing. A line capital PQ, 85 mm long, has its end capital P, 10 mm above HP and 15 mm in front of VP. The top view and front view of the line capital BQ is 75 mm and 80 mm respectively. Draw its projections. Also determine its true and apparent inclinations of the line. So this is the problem. C has given NP above HP and 15 mm in front of VP, and he has given the true length, which is capital PQ 85 mm, and he has given the top view, which is 75, and the front view is given to be 80. Draw its projections. Also determine its true length and apparent inclinations of the true and apparent inclinations of the line. So first is we will going to consider the first one. So what I am doing is, so first you have end P, which is 10 mm above HP. So when you look from the front view, I can see the distance above HP, which is 10 mm. And when it is looked from the front view, the image is projected onto the vertical plane, which is P dash, and this distance is above HP. Similarly, when you look from the top view, I can see the distance in front of VP. So in front of VP distance is how much? It is 15, that you can see in HP. When the top view has been looking from the top view, that has been projected into the horizontal plane, which is small p, and you write this capital P also. So he has given the top view distance. So what is the top view distance? The top view distance is given to be 75. So how to do that? The top view distance of 75 I can see only when you look from the top view. That means when the top view is parallel to XY line, then it's correspondingly in the front view you are going to get the true length. So what is the top view distance? The top view distance is given to be 75. So you have given the in front of VP distance. So that means in front of VP is 15 mm, that for the point P. So the top view of the other point Q will also be in front of VP by same distance. Then only the line is parallel to VP. So capital Q1, the small q1 is also in front of VP by 15 mm. Then only the line is parallel. You can see that the top view line PQ1 is parallel to XY line in the top view. So since it is parallel to the XY line in the top view, what is the distance of the top view? The distance of the top view is 75. So that means from here we will go to measure 75. So you got the point Q1. So when it is in space, what is the distance you are going to get? This is the distance. You have 15 mm here, and you can see the distance is 15 mm in front of VP. So since it is parallel to VP, so I am getting the true length here in the front view. How to get that? So from the front view, you take P, which is this point P, and from here you cut an arc on this end projector line, so that you will going to get this distance, which is 85. So when you look from the front view, that image will going to be fall on the vertical plane. You can see that capital Q, which has been shown till here. So now this length will going to be 85. So you mark that point as Q1 dash. Then once you get this line, then automatically you will going to get the locus of Q in the front view. So this will be P dash Q1 dash. Since it is the true length in the vertical plane, so that means capital P and capital Q, and this will go to be locus of Q in the front view. So you know that now this is the line which is in true length. So that means this image is also in true length, because its corresponding top view, small pq, is parallel to XY line in the top view. So you are looking from the top view, therefore that line image will going to fall here. So this line will going to be the true length line, which is 85 mm. Since in space this line is 85, when you look from the front view is perpendicular to this line, obviously that image will going to fall on the vertical plane. So now you got the true inclination with respect to HP. Now similarly, how to do that here in the orthographic view? First what we will do, we will going to draw the XY line and you mark VP and HP. So you know that NP is above HP by 10 mm and in front of VP by 15 mm. So from XY line, you measure 10 mm and draw a horizontal line. Similarly, from XY line, you measure 15 mm. It is in front of VP, is seen in HP. So you take below XY line and you draw a horizontal line. Consider any point. From there, you draw a vertical projector. You mark that point as small p in the top view, capital P dash, P dash in the front view, and you mark this as capital P, and here also. So here, then you got the one end of the line of PQ. So from P, you measure 75 mm in the top view, because if the top view line is parallel, correspondingly the front view is going to get the true length. So what we know is, if the top view line is to be parallel to VP, means what? The inclination with respect to VP is 0 degree. But he has given the top view, but he has not given the length, inclination. He has given the true length, but he has not given the inclination. And he has given the front view, but he has not given the inclination. So like this, you have only the magnitudes are given, but not the inclinations are not given. So if the inclinations are not given, then initially we will go to take, because since he has given that it is the true length since the true length is given, obviously if that true length is in vertical plane, then it should be parallel to XY line in the top view. That means the inclination with respect to VP is 0 degree, then only you are going to get the true length in the vertical plane. If the inclination with respect to HP is 0 degree, then only you are going to get the true length in the horizontal plane. So since he has given the true length, front view and top view, so I am making the inclination of the top view line with respect to VP as 0. Means what? It should be parallel to XY line or parallel to VP. P is in front of VP by 15. Q1 should also be in front of VP by 15. Then only the line will go to be parallel to XY line in the top view. You know the length of the top view. So from P, you measure the distance of 75 mm in the top view, and you mark that point as Q1, and then draw a vertical projector to the front view. On this vertical projector, you should get the true length of 85 mm. So by using the compass with P dash as center, take the radius of 85, cut an arc on this vertical projector and draw a horizontal dash dot line, and you mark this point as Q1 dash. Then join P dash Q1 dash with little bit thicker than the XY line. You mark this point as capital Q, you mark this point as capital P, then this as the locus of Q, and you show the dimension of 85 in the true length in the front view. So this angle will going to be theta. So this is how you will be able to write the orthographic view for the first position of to find the true length of the locus of Q in the front view when the corresponding top view will be parallel to XY. Once you do that, now we will go for the second case. What is the second case? So we have found out the true length in the vertical plane. Similarly, I have to find the true length in the horizontal plane. What is the true length in the horizontal plane? If the inclination with respect to HP is 0, then only you will be able to find the true length in the horizontal plane. So what is the length of the front view? The length of the front view is 80 mm. So if the front view line is parallel to XY, its corresponding top view will going to be in true length. You know what is the length of, what is the height, what is the distance of the point P with respect to HP. You have above HP by 10 mm, so that is this line. That is from here to here, it is above HP by 10 mm. Therefore, the other end point Q should also be above HP by 10 mm only. Then only the line is parallel to HP. Where you can see the line is parallel to HP, you can find that line in the front view. So by looking from the front view, you can see that the above HP by 10 mm, and Q2 dash is also above HP by 10 mm. Then only the line is parallel to XY in the top view. So which is the line which is in space for that? So this is the line capital P and capital Q. But when you look, so what I need to do, you know the front view, but he has not given the true length, its inclination. So I am taking the true top front view line which is parallel to XY. So that means P dash is above HP by 10, Q2 dash is also above HP by 10. Then only the line is parallel to XY line in the front view. Where you can see that, I can see that in the front view. Therefore, when you look from the front view, the image what you will going to get will be on the vertical plane, because the front view is perpendicular to the vertical plane. The front view is perpendicular to the vertical plane. So you mark this as P dash and Q2 dash. So what is the length of the front view? The length of the front view is 80 mm. So once you get that, correspondingly in the top view, you will going to get this is the true length line. What is the true length of this line? Which is going to be 85, because the true length is same both in the front view as well as in the top view. Therefore, once you get that, when you look from the top view, you can see the true length. So in the top view, that is this one, that is P and Q2. So once you get the true length in the top view, you got the locus of Q in the top view, you got Q2, you name that as Q2, and this is capital Q and this is capital P, and this will go to be the locus of Q. So the same thing I want to write it in the orthographic view. How to do that? So we are able to find the true length in the front view by finding out the locus of Q in the front view. Now we need to find the true length in the top view. So to find the true length in the top view, you need to have the front view line parallel to XY. You know the front view length, which is 80 mm. So how that the front view line will go to become parallel? P dash is above HP by 10 mm. So Q2 dash should also be above HP by 10 mm. Then only the line is parallel to XY. So from P dash, you measure 80 mm with respect to this vertical line, and you mark that point as Q2 dash, which is in line with P dash. So P dash Q2 dash is parallel to XY line in the front view, then its corresponding top view. So from Q2 dash, you draw a vertical projector to the top view. With small p as center, take the radius of 85, cut an arc on this vertical projector which is drawn from Q2 dash to the top view. Then join small p and Q2 with little bit thicker than the XY line. So you got the true length in the top view, you got the true length in the front view. Once you get this Q2, you mark this as capital P and you mark this as capital Q and this as the locus of Q. So now we have, and you measure you denote this as phi. It is the true inclination with respect to VP. So we were able to find the true inclination with respect to HP and also the true inclination with respect to VP. Now, what I need to find? I need to find the apparent inclinations, that is alpha and beta. How to find the apparent inclination? You know that the locus of Q in the front view is here. So now what should I do now? Next. So to find the front view or the top view. Now in this case, what I am doing is I am finding the top view now. Apparent inclination with respect to VP. How to do that? So with the P as center, taking the radius of PQ, I am drawing an arc such that Q is also in front of VP by this distance. How to do that? At present, Q is in front of VP by 15, but Q1, that is the top view of the point Q1, is not in front of VP by 15. Instead, that distance from here to here, it is the locus of Q. So with P as center, taking the radius of capital PQ here, I am rotating such that Q is also comes in front of VP by this distance, that is from here to here. So when you are doing that in this space, what happens when you look from the top view? Since the top view is perpendicular to HP, therefore the image from P to Q1 with P as center, taking the radius of Q1, PQ1, you are drawing an arc so that it will going to get the locus of Q in the top view. So you got the point Q, you mark that point as Q, then join PQ with a arc line. So you mark this angle as beta. So this is how I will be able to find the apparent inclination with respect to VP. When you rotate the line in space, what happens when you, by looking from the top view, that image is being rotated from P as center, PQ1 as the radius, you are rotating such that that Q will going to cut the locus of Q in the top view. And this is how you will be able to find the location of that is the apparent inclination with respect to VP in the problem. Now how to do that now? So actually we have this is the at present location of this point, that is P to Q, that is PQ1, which is parallel to X5 in the top view. But what happens, because not actually this line is not in this point Q1 is not in front of VP by 15, instead this Q is in front of VP by this total distance. So with P as center, taking the radius of PQ1, you draw an arc by using the compass, cuts the locus of Q in the top view and mark this point as Q, join P to Q with a dark line which is 0.5 by default when you are doing it in computer. But when you are doing it in manual, it should be thickest line in the drawing. So one should do that. So this is how I will be able to find the apparent inclination with respect to VP. Now, similarly, I want to find the front view now. So how to find the front view? So here, the front view, actual front view. But you know that at present where exactly your front view is. At present the front view is both P dash and Q2 dash is above HP by 10 mm. But actually Q2 dash is not above HP by 10 mm, but instead it is above HP by this distance. So without altering the length of the front view line, the point Q2 dash should lie on the locus line of the front view. How to do that? With P as center, taking the radius of this PQ, you are rotating like this such that Q is also above HP by this distance, which is the distance that is from here to here. So how do I do that? Without altering the length of the line, with P as center, taking the radius of PQ, you are drawing an arc such that Q is also not above HP by 10, instead it is above HP by this distance. Still such distance, you are rotating this line. So what happens to the image? When you look from the front view, since the front view is perpendicular, therefore this Q2 dash, which is above HP by 10 mm, is also being rotated such that it will going to cut the locus of Q in the front view. So you are going to mark this point as Q dash. Then join P dash to Q dash with a dotted line. So this is how you will be able to get the apparent inclination with respect to HP and apparent inclination with respect to VP. So how exactly you can do that when you are doing it in orthographic view? So we were able to find the true length in the, we are able to find the top view. Similarly, I want to find the apparent inclination with respect to HP, that is front view line I need to get. But actually till where we have done, till here we have done, that is to find the true length in the horizontal plane, I should have a line parallel to HP, that is P dash is above HP by 10 mm, Q2 dash is also above HP by 10 mm, then only the line is parallel to XY in the front view. But actually where exactly the point Q2, the locus of Q in the front view, the locus of Q in the front view is above HP by this distance. Therefore, with P dash as center, taking the radius of P dash Q2 dash, you draw an arc such that till where you need to draw the arc, till to the locus of Q in the front view. Once it touches the locus of Q in the front view, so that point will be considered as Q dash. Then join P dash Q dash with a dark line and you mark this angle as alpha. So then you measure the angles with respect to HP and VP for both true and apparent inclination. By using the protractor, you measure the angle true inclination with respect to HP, which is theta, which is 28, and apparent inclination with respect to the HP, which is alpha, which is 30 degrees, and then by taking the protractor here with reference to the point P, then you measure the true inclination with respect to VP, which is 5, which is 19.75 degrees or 20 degrees, and then with the same center, you measure the angle of apparent inclination, which is beta. So to do that, it will be 22 degrees or 22.52 when you are doing it in computer. So this is how you will be able to analyze the drawing and also to write the solution by using the sketchbook. So ultimately, how do I know that my problem is right? So you can see that when you join between Q dash and Q, both will going to lie on the same line. Then only your drawing is right. Otherwise, there is something wrong. So here, how to know that this is the front view? Because that is P dash Q dash is front view. Its corresponding top view, that is PQ, will also be inclined. That is alpha and beta. You know that this is the true length in the horizontal plane because the front view line is parallel to XY. That is P dash Q2 dash is the line which is parallel to XY. So PQ2 is in true length. Similarly, I want to find the true length in the front view. So this line is the true length in the front view because its corresponding top view will be parallel to XY. So this is how you will be able to analyze the drawing and also write the solution by using the manual sketch. Thank you.